Hello everyone. Today we shall discuss about laws of motion, chapter 4, from Aristotle's fallacy to Newton's mechanics. Property of physics. Student and lab notebook 4. Today we shall discuss about from Aristotle's fallacy to Newton's mechanics. The intuition trap, Aristotle's fallacy. The observation: if I stop pushing, the car stops, therefore, the force is needed for motion. Friction. Wrong. The car stops because of an opposing force, friction. Aristotle thought the natural state of rest. He missed the hidden forces. In a frictionless world, motion never stops. Breakthrough The breakthrough Galileo's law of inertia. Inertia is the resistance to change. Mass is the measure of inertia. You see, a ball is going here, reaches to same height, travels longer distance, rolls forever. That is, if net force is zero, a body at rest stays at rest and a body in motion continues with uniform velocity. Newton's first law of motion. Every body continues in a state of rest or of uniform motion in a straight line unless compelled by some external force to act otherwise. Inertia wants to stay at rest. We don't fall because of a force pushing back. We fall because upper body stays put. If net force zero, then acceleration is equal to 0. The quantity of motion, momentum, is mv, and you know that momentum is a vector quantity. A small mass m, this one, huge velocity v, high impact. The mass is small but the velocity is huge, the impact will be high. Huge mass m, small velocity, hard to stop. Note, momentum is a vector, it has direction also. Newton's second law. The rate of change of momentum is directly proportional to the applied force. That is, F is directly proportional to del P by del T, or F is equal to K dP by dt, or F equal to ma. Vector law, x force changes only x velocity. Unit, the Newton. 1 Newton causes an acceleration of 1 meter per second square to a mass of 1 kg. That is the definition of 1 Newton. Impulse, force over time, short time, density, huge force F, there is lot of pain, long time, density, small force F, safe. So impulse is equal to force into duration. Del P is equal to change in momentum. We use airbags for the same reason. Newton's third law. To every action there is always an equal and opposite reaction. Action, the force of fall on the man applied. Reaction, force on man, the wall applied. So F of A be equal to minus F of BA. Warning, do not cancel them out. Action and reaction act on different bodies. Conservation of momentum. In an isolated system, total momentum is conserved. Here you see initial momentum equal to final momentum. Minus P, cannon, this is plus P, ball, in this way. So, total momentum is 0. M of mass of ball, velocity of ball plus momentum of cannon plus velocity of cannon equal to 0. Applications, collisions, explosions, recoil, all the applications of Newton's third law of motion. Equilibrium of a particle. Equilibrium means net external force is 0. Normal force, weight mg. Forces cancel out. Vector sum F1, F2 plus F3, they will be the same direction. The vector sum will be 0. A particle in equilibrium is either at rest or in uniform motion. Patrick Hunt, Midnight Blue. Common forces, friction, microscopic view. In friction, you see this is a microscopic view of surface. So we have two types of friction, static friction and kinetic friction. Opposing impending motion, self-adjusting. That is, Fs is less than equal to mu s into n. A kinetic friction opposes actual motion, constant, Fk equal to mu k into n. And you should remember that mu k is less than mu s. It is easier to go moving than to start. Circular motion, level road. This you can see here. What turns the car? The friction provides the centripetal force. Fs mv square by r. Max speed v max root over mu s rg. If you go faster than this, you skid. So in this way you can find the different ways of motion. Thank you. Right? Now we learn this way the car turns and what gives the centripetal force? F is equal to mv square by r. The circular motion, the bank road. You see, this is the bank road. This is n sin theta. This is n. Banking tilts the normal force to help turn the car. Optimal speed, no friction needed. V 0 equal to root over Rg tan theta. Reduces the tire wear. The mechanics problems. Solve for checklist. Draw the assembly. Sketch the scene. Isolate the system. Pick one body. Draw the FBD free body diagram on the forces on the body. Choose axis x and y. Apply Newton's second law. Summation fx equal to maximum. Summation fy equal to may. This is max. And solve for unknown. This is the process to solve problems. And the last one is the chapter summary and check sheet. That is f equal to ma, p equal to mv, impulse equal to f, del t, fs is less than equal to mu s into n, and v bank equal to root over rg to tan theta. Force is the cause, acceleration is the effect, mass is the resistance. Thank you everybody for watching this video.